So the first thing that we're going to do is enter the given equations into our calculator. So the given equations were f of x equals x cubed minus 6x plus 1, and g of x equals 5x plus 1. So we're going to hit the y equals button, and in the first equation space, we're going to hit x cubed minus 6x plus 1, and in the second spot, we're going to do 5x plus 1, and we're going to hit graph. It looks like we don't need to see as much of the x-axis, so we're going to change that to -5 to 5 and hit graph. Yeah, see, that looks a lot better. I think we can still do more though, because you see that these are cutting off 2 more intersection points. So we're going to hit window again, and we're going to make the y minimum and maximum bigger. So we're going to say -20 and 20. And we're going to hit graph. So, as you can see on this graph, the 2 equations that we had 3 intersection points. So we're going to go ahead and find them. So we are going to find the first intersection point right here. So the way we're going to do that is we're going to say second trace. We're going to go down to number 5, intersect, and it asks us the first curve. So we're going to say that the first curve is right there. And the second curve is right there. So it's going to ask if you want a guess. So you're going to click enter. And that's the intersection point. So let's write that on our paper. And finally, our third intersection point right there. Same thing. Second trace, intersect, first curve, and second curve. In our graph, that's the function that sort of made a wavy line. So we're going to say that the domain was -infinity to infinity. And the range, as you can see, is also -infinity to infinity. So now we are going to do the same thing for g of x. And g of x was 5x plus 1. So it is a linear equation. So the domain is still -infinity to infinity. And the range is also -infinity to infinity. So the last thing that we have to do is graph both of these functions. So we have to be careful because our window wasn't just -10 to 10 on both the y and the x-axis. So we have to make it so that the x minimum and maximum are -5 to 5, and the y minimum and maximum is -20 to 20. So now that we've done that, I'm going to go ahead and try to find the zeros of the 2 functions. So I'm going to say second trace, number 2, 0, and it asks you left bound, so right there, and right bound, which is right there. So that's its guess, so I'm going to go plot that. So now I'm going to find another 0, so second trace, 0. I'm going to try to find this one, left bound, right bound. That's its guess. So now to make my graph a little more accurate, I'm going to try to find the local maximum and minimum of this cubic function. So I'm going to go second trace, maximum, left bound, right here, and right bound. And I'm going to record that point. Now I'm going to find this minimum. So I'm going to do something similar, which is second trace, minimum, then left bound and right bound. And I'm going to plot that point. So now that we've done all of these points, I'm going to sort of do like a little game of connect the dots. And I'll show you what it's like when I'm done. Alright, so now we have our beautiful cubic function, which was the f of x function. So now I'm going to graph the g of x function. So basically it's just going to be a straight line from the 3 intersection points. So it's going to be from here to here to here. So I'm going to draw that and I'll show you 1 second. So that is the graph with both of the functions on it. So the last thing that I'm going to do is I'm going to label the intersections. So that's the finished product with all of the intersection points labeled and the axes numbered. So I hope you enjoyed this video. I'm Elena Jacob.